Oh, welcome back, everybody. It's so nice to see you all here with us again this evening. Hi, Megan. Hi, Carol. Hi, Nzole. Sabisi family. I'm not sure who that is. Sihle, nice to have you with us. I didn't think you were with us last time on Tuesday, Sihle. Have any of you written paper 1 and paper 2? Writing paper 1 tomorrow, Megan. Okay. Oh, you were here. Oh, okay, Cece. I don't remember seeing your name on Tuesday. Okay, so Megan, you're writing paper 1 tomorrow and paper 2 on Friday. Tomorrow's Friday, Megan? Monday. Okay, all right. Cece, no, you're writing next week. Okay, that's fine. Paper 2 Monday, says Carol. Thank you, Carol. Are most people finished with paper 1 and writing paper 2? Ah, see, I know when you're not with us, Sihle. I missed you, you see. So let's get underway. I don't want to waste any time. I just wanted to make sure that I am doing the right thing for you guys. I had sort of figured, judging on the conversations, I missed you too, Sihle. I'm really glad you're back with us. Just judging on the conversations that we had, I figured that doing paper 2 again this evening was probably better than doing paper 1. And I know trigonometry is always a sticking point for a lot of students. So that's what I prepared for this evening. Are you guys all happy with that? Does trig suit you? You can give me, hi, Jared. You can give me a thumbs up. Are you happy with trig, guys? Thanks, Sihle. Cool, Jared. Thank you. You happy with paper 2, Carol? Kelebohile? Thanks, Kelebohile. Nzuli, I know you've already, thanks, Carol. I know you've already written, but you know, being part of the lessons, even though you've written, is still going to be helpful to you. So that's no problem. Okay, and of course, like always, guys, if you've got any questions or something doesn't make sense, please stop and ask questions. I love it when you interact with me and we can have a conversation about what's going on. So yeah, no worries about that. Okay, so let's have a look at the first question that I have put on the screen. And that is sort of a pretty typical exam type question, I guess. And they have asked us to have a look at triangle QPR, which is right angled as it would be in grade 10. And they've told us that the right angle is at P. Then in question 3.11, they've asked us to use the sketch to determine the ratio of tan 90 minus R. All right, now I liked this question because it's out of 1 mark and it's actually very, very easy. But if you don't understand what they mean, then you're kind of looking at it and you're thinking, well, what do they mean by using the sketch to determine the ratio of tan 90 minus R? Okay, so when they want the tan of an angle, so if you recall from SOHCAHTOA, do you remember SOHCAHTOA? We spoke about that when we did SOHCAHTOA. And if we focus in on the tan of any angle, we know now in grade 10 that that means the tan of any angle, so the tan of any angle, whatever we call it, theta, alpha, beta, A, whatever, okay, is going to be, can you remember? Opposite, over, adjacent. That's it, opposite over adjacent. Okay, but opposite and adjacent only exist in a right angle triangle in relation to a particular angle. So it's the side, when we talk about opposite, we mean the side opposite this angle. When we talk about the adjacent side, we mean the side that is adjacent to this angle. So here they have given us tan, and they've given us the angle in brackets. So the angle in this case is 90 minus r. So what else could I call 90 minus r when I look at this diagram? What other angle could be 90 minus r in the diagram? You guys know? So 90 minus r is just a fancy way of saying angle Q. Why? Why is 90 minus r a fancy way of saying angle Q? Well, if we think about it, all right, angles of a triangle add up to 180 degrees, right? So we know angle P is 90. Exactly, Nizoli. So we know angle P is 90, right? If we add angle R and we add angle Q, we know that we're going to end up with 180 degrees, yes? Okay, so if we now want to collect the 90 and the R on the other side, right, that would mean leaving the Q on the left-hand side. If we take this 90 over to the other side, 180 minus 90 is 90. And if it's positive R on the left, it needs to be minus R on the right. Okay, so calling angle Q, Q, or calling it 90 minus R, it means the same thing. Okay, so another word, another description for angle R would be 90 minus Q. Does that make sense to everybody? And this is actually super important, this 90 minus. You're going to see a lot of that next year when you go into grade 11. So it's very important to understand that, you know, if we've got a right angle triangle and obviously two other angles as well, that the other two angles can both be defined in terms of 90 minus the other one. Okay, does that make sense to everybody? So really what they're doing here is they're asking us to determine the tan of angle Q. Okay, so in relation to angle Q, which is this angle over here, which side is the opposite side and which side is the adjacent side? So opposite from Q would be side what? Carol, do you know? Opposite angle Q is side what? Good, Jared. Okay, nice. Well done. Is side PR. Okay, Jared is right. Opposite. Okay. Yes, Carol, quite right. PR, opposite. Okay, and adjacent to Q would be side. Indeed, Carol. Good. Well done. Okay, so that's what they wanted from us here. All right, the ratio, here's our ratio, PR over QP. Okay, and that's what would get us our 1 mark in this situation. Can I just have a thumbs up that you understand what I was talking about with angle Q being 90 minus R? Does that make sense to everybody? Okay. You sure? Okay. All right. Okay. Thanks. Thank you for the response. All right, then in question 312, it asks us to write down the trigonometric ratio that is equal to, and now they give us the sides. So in other words here, either they've given us an opposite and adjacent, or they've given us an opposite and a hypotenuse, or they've given us an adjacent and a hypotenuse. So what we need to do is need to have a look at the diagram very carefully and see how these sides are related to an angle. All right, so side QR is this one over here, and I'm just drawing a squiggly red line. What is side QR always, always, always? What's it called? It's called the hypotenuse. That's right. Okay, it's called the hypotenuse. It's opposite the right angle. The hypotenuse is always opposite the right angle, and it's always the longest side in any right angle triangle. So straight away, we know that we've got an H at the top. Okay, we've got hypotenuse at the top. QP, let's just get a different color. QP is this blue side over here. Exactly. So that, well done, Namusa, that is adjacent. Okay, it would be adjacent to Q. All right, so now if they want us to write down the trigonometric ratio that is equal to hypotenuse over adjacent, what they're asking us for, and I don't know if all of you did this year, but this is normally part of the grade 10 syllabus, is they're actually asking us for a reciprocal ratio. Did you do reciprocals? I know some of you who attended the trig course that we did earlier this year, you said that your teachers had left reciprocals out in order to sort of catch up with COVID and all that kind of thing. But technically speaking, it should be part of the syllabus. Do you know what I'm talking about when I talk about a reciprocal? Sihle, you're almost right. Okay. So the cos of any angle, Sihle, is A over H. But this is H over A. So it is the sec of the angle. That is the reciprocal, is H over A. Okay, so here the trigonometric ratio that's equal to QR over QP would be sec Q. That's it, Nizoli. That's it, Nizoli. Sec, cosec, and cot. Okay, Namusa, yes, you do know what the reciprocals are. Okay. All right, Sihle, good, well done. So that's what they wanted from you in this particular case, was a reciprocal. Okay, so yeah, you asked, as I say, it is something that should be taught in grade 10, but I do know that some of you said your teachers hadn't done it because of time constraints and that kind of thing. What is good to know, and I think this is one of the reasons why your teachers would have left it out, is that we don't, thank goodness, we don't use cosec, sec, and cot in grade 11 and grade 12 in the CAP syllabus. So that's why I think that's it. Shade your rear because X-rays tan your exterior. That's it. Oh, look, here's Sihle. Yes, exactly. That's quite right. And that was one of the questions that I was actually going to ask Sihle is, do we understand what the word reciprocal means? Do we understand what we mean by a reciprocal? Because, you know, it is something that we use in maths on a regular basis. So a reciprocal, just very quickly, maybe what I'll do is just put that over to the side. But an example of a reciprocal here is this. So if you have a fraction, and let's say you've got 2 over 5, okay, so the reciprocal means switching the numerator and the denominator. So the reciprocal of 2 over 5 is 5 over 2. So that's why when we said cos theta is equal to adjacent over hypotenuse, the reciprocal ratio is sec theta, and it is hypotenuse over adjacent. Okay, that's it. Perfect. Okay, 100%. Just switching the numerator and the denominator. Beautiful. Simply put, that's exactly what we want. Okay, good job, Sihle. Thank you very much. So another thing that's a very common question in trig is a question like number 3.2. Now, I don't know what your teachers at school call these, but I call these lollipop diagrams because, I don't know, to me, this just looks like the stick of a lollipop and, there's a bit of a circle going on here. So I always call them lollipop diagrams. That's not a official name or anything, but that's just what I refer to them as. But really what we're doing here, grade 10s, is we are working on the Cartesian plane. All right, so very important for us to remember your terminal arm, so line OS, is anchored at the origin like the hand of a clock, okay, like a fan, a ceiling fan, okay, and it's anchored at the origin and it swings in an anti-clockwise direction, okay. When we move in anti-clockwise direction, our angles are getting bigger. For us in maths, what this means is that we have decided that this is 0 degrees, this is 90 degrees, okay, so that's why that's a right angle. This is 180 degrees. This is 270 degrees. And if the terminal arm was to swing all the way back and end up back on the x-axis, then it would have done a full 360 degrees. Okay, so that's why angles get bigger when our angle of inclination is measured in an anti-clockwise direction. Okay, you'll learn more about negative angles next year, which is just a change in direction. So this terminal arm has swung through 180, come to rest somewhere between 180 and 270, and at the end of the terminal arm is point S. What do I actually call this place on the Cartesian plane where this terminal arm has come to rest? What is it referred to? Does anybody remember? No? You're all feeling shy and shattered and quiet tonight, hey? All right, so just very quickly, please stop me if I'm telling you stuff that you already know. Yes, Nizoli, that's quite right, absolutely. Yeah, I was going to say, please stop me if I'm telling you stuff that you already know, then I don't want to waste your time. Okay, so if this is an x-axis and this is a y-axis, if you recall, this it cuts this area into 4 separate regions, each called quadrants. So this is always quadrant 1. This is always quadrant 2. As Nzole said, our terminal arm has come to rest in quadrant 3. And then this quadrant over here is always called quadrant number 4. All right, now the defining characteristics of quadrant 3 is that both x and y are negative. All right, so we're working to the left of the y-axis and below the x-axis, so both x and y are negative in this case. The first thing that they want us to do without the use of a calculator is to determine the length of OS. All right, anybody know how we're going to do that? What are we going to use to work out OS? Anyone remember? Okay, so I'm drawing something here to help you guys. Not distance formula, not distance formula.
Pythagoras theorem.
That's it, Nasisa. Well done. Good. All right. Now, the reason that we're using Pythagoras theorem, yes, Namusa, we are making it a kind of construction. Can you see what I've done here, though? I have joined S to the x-axis, and I have made, excuse me, a right-angled triangle. Okay, so whenever your terminal arm comes to rest in any one of the quadrants, you can always draw a line from your end point of your terminal arm to the x-axis, and you can make a right-angled triangle. That allows you to use the theorem of Pythagoras. Okay, remember your first coordinate is always your x. Your second coordinate is always your y. And when we work with the theorem of Pythagoras, we say x squared plus y squared equals r squared. Okay, so when we are working with the theorem of Pythagoras, x and y represent coordinates on the Cartesian plane. X and y are always the coordinates at the end point of your terminal arm. R is another word or letter, should I say, for the terminal arm, aka OS, aka the hypotenuse. Okay, so R is the hypotenuse. Otherwise also known as the terminal arm when we're working on the Cartesian plane, the terminal arm. Okay, so we're now going to come along. Very, very important. When we substitute, we must substitute in brackets. Okay, putting exponents on the outside. Okay, so -3 must go into brackets. -4 must go into brackets. Equals r squared. So that gives us 9, that gives us 16. That means that r squared is equal to 25. Now, unlike if you are solving for x and y, r can only have one sign. R is a distance. It's the length of the hypotenuse. It's the length of the terminal arm. R is always positive. Only x and y change sign. Okay, so x and y change sign depending which quadrant you are in. It does not matter as far as the terminal arm or the hypotenuse is concerned, because its distance is always going to be positive. Okay, so here r will be equal to +5. So therefore, OS is 5. All right, so they've given us 2 marks here. 1 mark would be for knowing to use the theorem of Pythagoras. The other mark would be for the answer. How does that feel? Does that make sense to everybody? Is this sounding familiar to you? Yes, you know it. Oh, good, Jared. Okay. Everybody else? Cool, Harry. Thank you. Okay. No, that's fine, Sihle. Okay, how's everybody else doing? Is it making sense? Oh, good. Thank you. Thanks, Kaki. Thanks, Lisejo. Good job. All right. It is. Cool, Namusa. All right. Lovely. So now, based on the value of OS, they now want us to calculate sec theta plus sine squared theta. Oh, Nzoli, you are so funny, seriously. Well, in a question like this, Nzoli, not really. They wouldn't really be able to, they really wouldn't be able to tell if you'd used a calculator or not. So, but I think what's important here is if you show this line of working here, and you show that line of working here, and you show that one over there, even if you did use a calculator to help you, they wouldn't know, not with something like that. Okay, yeah, but yeah, we are supposed to be able to do Pythagoras without a calculator. But anyway, all right, 3.2.2. So sec theta. So there again, we see sec theta plus sine squared theta. Now, a lot of students struggle to understand what it is that they're exactly looking for in a question like this. Before answering anything like that, what I would always do, I don't know if you remember me telling you this when we did trig, is I would always write down, I know what the value of x is. They've given it to me. I know it's -3. Right? I know what y is They've given that to me as well. It's -4. And I know what R is now because I've just calculated it. Right now, I can't remember who it was, but someone earlier said, who was it? Someone said shade your rear because X-rays tan your exterior. I'm not looking in the chat, but someone said it. So shade your rear because X-rays tan your exterior. Okay, so that is the Cartesian plane version of SOHCAHTOA. It's the same thing, all right? It's exactly the same thing as SOHCAHTOA. Okay, so sine is opposite over hypotenuse, sine is y over r. Cos is adjacent over hypotenuse, cos is x over r. Tan is opposite over adjacent, tan is opposite or y over x. Okay, so this one over here, shade your rear because X-rays tan your exterior, is actually the more important one of the two. That's the one that you're going to be using next year in matric. We only use SOHCAHTOA in grade 10. So what we have to do now is we have to go back and say, well, what does sec theta mean? So if you recall, sec theta was hypotenuse over adjacent, which really, when we're talking about shade your rear because X-rays tan your exterior, really means what over what? What are they really asking for in terms of this? H is now written as R. Yes, exactly. Sec is R over X. Yes, exactly. Exactly. So the reason why you need to know that is because here you've got X, Y, and R. You don't have O, A, and H. All right. So straight away, we can write sec theta for this particular question is going to be 5 over -3. Okay, so that would be, in this case, it would be 5 over -3. I'm just subbing in. Yes, exactly. So, yes, with pleasure, I can explain again. So we have worked out, when we have been given one of these diagrams, it's always our job to know what X, Y, and R are for the diagram. Okay, irrespective of which quadrant the terminal arm has come to rest in. Okay, so X will always be the X coordinate at the end point of the terminal arm. Y will always be the Y coordinate at the end point of the terminal arm. And R will always be positive, all right, because that is the length of the terminal arm or the length of the hypotenuse. When they are asking us a question like this, sec theta, they are referring to sec theta in terms of this particular diagram, okay? So our reciprocals, Kaki, let me just move this over here. All right, if you don't know the reciprocals, then this does make this a little bit more tricky. Okay, so sine theta is y over r. That's where shade your rear comes from, okay? Cos theta is x over r, because x-rays, and tan theta, your exterior. Okay, so the reciprocals, and somebody, I think it was Nizoli, I can't remember, somebody put them in there for us. Okay, so the reciprocal of sine theta is cosec theta. And a reciprocal means moving what was in the denominator into the numerator and what was in the numerator into the denominator. Okay, Sitle said that for us in our chat as well. Okay, sec theta is the reciprocal of cos theta. And that means r at the top and x at the bottom. We've switched these two around. And tan theta, its reciprocal is cot theta. And that's when we've got x at the top and y at the bottom. Now, Kaki, you have to learn these. Okay, this is something that you have to just learn off by heart. All right, but hopefully now you understand what it means and where it comes from. So that's how I know what they're asking for. When they're asking for sec theta, they're asking me to write r, the length of the terminal arm or the hypotenuse, over the x coordinate. All right, that's what the instruction is. The other thing that they've included in this particular question is sine squared theta. Okay, so when I talk about sine theta, now that's something completely different, all right? What they're asking you to do there is that they're asking you to calculate an angle, all right? So that is the inverse of sine, okay? It's actually called arc sine. And that is when we use the ratio to calculate the size of the angle. Okay, so we're working backwards to calculate an angle. All right, so normally what you would see on your calculator is this. Okay, when you press shift sign. Okay, but that's to calculate an angle. All right, we're not interested in working out angles here. Okay, we're simply interested in working with the ratios of the sides. Okay, so if sine theta is y over r, if sine theta, silly pen, if sine theta is y over r, then sine squared theta is y over r squared. That's what it means. Okay, so if sine theta is y over r, sine squared theta is y squared over r squared, essentially. Ooh, it's a funny looking square, y squared over r squared. Now what we have to do is we have to go back to our diagram and we have to substitute in the values that they gave us. Right now, they want us to do this without a calculator. So let's go back to our diagram and go and have a look at what we've got. Okay, so just grab my pen. Okay, so sec theta plus sine squared theta. We all agree now, we know that sec theta means r over x, and we know that sine squared theta means y over r squared. Now you can substitute from here, because there is your x and your y and your r for this particular question. All right, so r in this case is 5. X is -3. Y is -4. R is 5. Got to put brackets around it. Got to square it. So now, Nizole, now they could see if you were going to use a calculator or not. Okay, so you would need to be careful about the amount of working that you showed. I mean, if you went straight from this line over here, Nizole, to the answer, then your marker is going to know that you used a calculator. All right, so whoever would have thought that fractions, when we learned about fractions in grade 8, that it had so much to do with trigonometry later on, and it does. Okay, so being able to do trig also means being able to work okay with fractions, all right, which is not something that a lot of people enjoy, but anyway, never mind. Okay, let's go through this. So whether I write the negative at the denominator or at the numerator or in front of the fraction, it really doesn't matter. It all means the same thing. So I'm going to do that, okay? So no calculator. -4 times -4, you all know is 16. And 5 times 5, you all know is 25. Now we need to add these two together. We can't add fractions that have a different denominator. So we need to find a lowest common denominator. All right, so what is the smallest number that both 3 and 25 go into? I guess the easiest thing to do really is just multiply the two together and work with that. So we can always simplify it afterwards. So 3 times 25 is going to leave us with 75. Okay, so we have to times the bottom. Let me just change color. So I have to multiply the bottom by 25. So I must multiply the top by 25. Okay, so 5 times 25 will leave me with negative 125. Here I have to times that by 3. So I must times the top by 3. Okay, so that's going to leave me with 48. Right now, I think if you show all these steps, okay, your teacher can't penalize you. Okay, and then the last step, and I think this is where it's okay now to use a calculator. So go minus 125 as plus 48, and then what do you get? That's it. But isn't it minus, Namusa? Minus 77 over 75? Okay, because if, yes, no problem. No problem at all. Okay. So what do you guys think? What do you think of question 3.22? Does it make sense? Did you know that that's what it meant? Would you have been able to do it on your own? Cool, Nizole, no problem. Okay, so Carol, that's fine, Carol. I want you to be honest. Okay, Nasisa, you said the same. Okay, all right. So this question that I've done with you now is a really, really important question. Okay, so next year in grade 11, you're going to be asked the same type of question, but there's going to be new information that gets added to it. So it's so important for us to understand these basic concepts. And then the same thing is going to happen in matric. You're going to be asked the same kind of question. All right. I'm so glad, Lesejo. I'm so glad. Yeah. No, absolutely. It's definitely challenging at first. I mean, this is not straightforward, Jared. There's no doubt about that. But you know, once you begin to understand what it means, then you understand how to answer the question. All right. So the trick to conquering trig is to study. You have to study, like you have to study for history, or you have to study for life science, or you have to study for physical science. Maths in grade 10, 11, and 12 is a learning subject. Okay, so you have to learn your ratios. You have to learn your reciprocal ratios so that you can answer these sorts of questions. Okay, because if you haven't learned what sec theta means, you can't answer this question. If you haven't learned shade your rear because x-ray is tan your exterior, you don't know what sine squared theta means. Okay, so take the time to go and study those things, because you're going to need them, not just this year, but your future self is going to need them, okay, in grade 11 and in matric. Okay, so there we go. That question was out of 3. I think what they would have done here is they would have obviously given, okay, it's my pen, they would have given us a mark for the answer, of course. There would have to have been a mark for subbing in. And then I imagine somewhere over here, there would have been some sort of mark for simplifying or finding a lowest common denominator or something like that. Okay, so Nzole, you can tell your friend that I said, as long as you show all your steps, you should be okay if you use your calculator. Okay. All right, let's have a look at question 3.3. And again, look here, Nazoli, determine the value of the following without using a calculator. You will always see that in trig, always, always, always. Okay, so that's why it's so important for us to know our times tables, to know how to work with fractions, etc., etc. All right, but anyway, we can use the calculator in that very last question, which will last little bit of that question. Okay, so now question 3.3, determine the following without the use of a calculator. All right, so now cosec 45. Okay, so let's write that down. You think you would have got it. Okay, Nazoli, that's fine. Perfect. And then they also gave us sine 90. Who knows what this question is testing? Again, it's another learning question. Anybody know what this question is testing? This is all about? Special angles. Okay, does that sound familiar? Special angles? Yes. Okay, so now, Carol, your special angles are super, super important. You first learn about them in grade 10, and then it kind of all goes a little bit quiet in grade 11, and then you sort of get the impression that they weren't that important, and then they come back with a vengeance in matric. Okay, so learning your special angles is really, really important. Now, there's lots of different ways that teachers teach students how to remember special angles. There's a fan, there are triangles, there's a table. My personal favorite is the table. And again, this is something that you have to learn. Okay, you have to go and study it, so that when you are asked a question like this, you're able to answer it. So your special angles table, one way of remembering it, and I think this is a pretty cool way of doing it, is like this. Okay, so remember, we're working with shade your rear because X-rays tan your exterior. All right, so what we do is we put Y at the top, X in the middle, and R at the bottom. Okay, our special angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so Nazole, did you use a calculator? I'm just teasing you. Okay, you probably could use, well, you could use your calculator to work it out, but they, again, they would expect you. Okay, so Nazole, cosec is what? Cosec theta is R over Y? Okay, because it's the reciprocal of? That's it. Okay, because it's the reciprocal of sine theta. Okay, so sine theta is Y over R, so cosec theta is R over Y. Now, what you have to learn with special angles, okay, is that when it comes to your special angles only, your R is 2. Okay. Then it comes to filling in these tables. What we do is this. All right, we start, let's use a different color. We start at 0 and we go 0, 1, 2, 3, 4. And then we start here and we go the other way, 4, 3, 2, 1, 0. Okay, and then what we have to do is we have to take the square root of all of these. Now, the square root of 0 is 0. The square root of 1 is 1. Okay, the square root of 2 is root 2, the square root of root 3 is root 3, the square root of 4 would be written as 2. Okay, so here the square root of 4 is 2, that's root 3, that's root 2, root 1 is 1, and root of 0 would be 0. So all of these we have to take the square root of, okay? This you have to learn off by heart. Now, I don't know about you guys, but to me, learning it in this table makes the most sense. So when they are asking us for this question, it really is about, first of all, recalling all of this and then going and subbing in. All right. So the way the table works is like this. Okay. Let's say, before we answer the question, I agree with the tan root 3 over 1, but the sign of 90. Yes, no, that's right. That's correct. It's perfect, Nizuli. Well done. Okay, good. Okay, so before we do that, let me just show you how this table works, right? So if somebody comes along and they say to you, what is the sine of 30? You have to remember, shade your rear, because X rays tan your exterior. So sine is Y over R. So you find the column with 30 in it, Y is 1, and R is 2. Okay, grade 10s, that's how it works. Somebody comes along and they ask you, what is the tan of 60? You have to know that tan means Y over X. So root 3 over 1. Okay, just like Nizuli said. If they come along and they ask us for the cos of 45, we need to know that cos means X over R. Okay, so we're going to find X, that is root 2 over R would be 2. Do you see how the table works? Okay, so you have to learn it. There's no other way around this. Okay, so trig is all about learning special angles, learning your ratios, and then you'll see next year there's a whole lot more stuff that you need to learn as well. Okay, so going back and answering our question now, let's just rub this out. Okay, so cosec 45, okay, is R over Y, like Nizole said. Okay, so we're going to go to the column with 45 in it. Okay, that's this column over here. And we're going to write cosec 45 as 2 over root 2, R over Y. So 2 over root 2 divided by the sine of 90. We're looking at the last column. The sine of 90. How are we going to write that? Can somebody else tell me? Or mine just Nizoli's already told us. We're going to write that as Y over R. So 2 over 2, which is the same as 1. So 2 over 2, there's a dot there, so that means times. And then the tan of 60. So tan means Y over X, Y over X, so root 3 over 1. Okay, so now we need to simplify this. And again, Nizoli, if we go and use a calculator to work out our answer, and we've just got an answer now, then the teacher's going to know that that's what we did. All right, so we've got to be able to manipulate this complex fraction without the use of a calculator if we want all the marks. So going back to grade 8, does anybody remember the rules for multiplying and dividing fractions? What do we do when we multiply fractions? So if I have 1 over 2 times 1 over 3, how would I multiply those together? Namusa, you're getting confused with division. So, but you're on the right track for division. But when it comes to multiplying fractions is the easiest. Okay. All you do, and again, this is something that you have to learn. All right. You've got to multiply numerator with numerator, not cross multiply. And so I'm so glad you said that. Everybody says cross multiply. And let's talk about what cross multiplying. Yes, you just do it. So 1 times 1 is 1, and 2 times 3 is 6. Okay, so when you multiply fractions, you multiply numerator with numerator and denominator with denominator. Now, hang on a second. I'm so glad you said that, all right? I want to just show you something, okay? This is where it's so easy to get confused with math. There's so much going on. When we say cross multiply, so cross multiplying is a method for solving equations. Okay, so when we solve equations with fractions, oh, no, Wazi, don't worry. Oh, 10 minutes before the end. I'm glad you could join us. So when we solve equations with fractions, that is when we cross multiply. So if you have something like x over 2 equals 10 over 3, this is where you're going to cross multiply, all right? So in other words, you're going to say 3 times x is 3x equals 2 times 10 is 20. That's cross multiplying. That's cross multiplying. Okay, in this case, x would be equal to 20 over 3. Now, we are not solving for x here. All right. We are working with fractions. So cross multiplying is for solving for x. When we multiply fractions, we multiply numerator with numerator and denominator with denominator. Yes, Nawazi, you will be able to watch the whole thing. Tula will be able to tell you. Okay. What's that, Nzole? I don't understand what you mean on YT. Oh, on YouTube. Oh, yeah. Yeah, quite right. You too sharp, Nzole. Okay. Dividing fractions. Okay, now, I think it was you, Namusa. You were saying something about crossing and tipsing and timesing or whatever it is. So now, let's say they give you this. And I'm literally just pulling things out of my head here. 10 over 3 divided by yes, Norwazi, that would be correct. That would be correct. Okay, so divided by 5 over 14. Okay, what we have to do is, I don't know, it wasn't you guys that I was discussing this with, it was the grade 7s, but it's keep, flip, change. So KFC, or another way of remembering this is, it's gone straight out of my head now. Different times. Different times. Okay, so we keep the first fraction the same. There we go. That's right, Namusa. And then we put what was at the bottom at the top and what was at the top at the bottom. Now, in Tlafatso, we can cross cancel, not cross multiply. Oh, I suppose we could cross multiply here. Not cross multiply, we could multiply numerator with numerator and denominator with denominator, but we are allowed to cross cancel. All right, so now what that means is that we can say to ourselves, okay, 5 goes into itself once and it goes in here 2 times. 7 goes into itself once and it goes in there 2 times. And now you're multiplying fractions, multiply top with top, bottom with top, bottom to, that's going to give us, let me just plug my laptop in. With me, that's going to give us 2. Okay, so 2 times, oh, I'm talking absolute nonsense. It's going to give us 4, beg your pardon. Okay, so because 2 times 2 is 4. Okay, so 4 over 1, which would be 4. All right, does that make sense to everybody? Do you remember that? Okay, so again, knowing how to work with fractions is so important in this situation. BODMAS tells us that we have to multiply before we divide, all right? So in other words, we're obliged to multiply these 2 together first. So now we're going to end up with what we call a complex fraction. A fraction over a fraction, and you're never allowed to leave that in maths. You've always got to simplify it. So we're going to have 2 over root 2, which is our numerator. And then at the bottom, how do we multiply fractions? Numerator with numerator, denominator with denominator. So 2 times root 3 is 2 root 3. And 2 times 1 is 2. So this over here, this is what's referred to as a complex fraction. In other words, a fraction over a fraction. All right. Now, it means the numerator divided by the denominator. Okay, so let's just write that down. Absolutely correct. That's the whole idea behind maths. As soon as you start to learn the rules and you understand the theory, you can do anything. But without that, it's impossible. Okay, you have to know what things mean. So when you are studying for maths, the first thing that you do is you open your book and you study the rules. Once you have studied and you have learned the rules, then you go and practice the questions. And then when you finish practicing the questions, then you go and work on the exam questions. That's the way to do it. Okay, you have to. There's no other way to do it, unfortunately. Okay, I better hurry up and finish off here because I'm getting kicked off at 6. We've got load shedding starting. So I just want to finish this off before I have to go. So this means 2 over root 2 divided by 2 root 3 over 2. And just like with our dividing fractions question that I had done over, where was it, over here, where we did tip and times or keep, flip, change, it's exactly the same thing. We're going to do exactly the same thing here. So we're going to keep 2 over root 2. We're going to change, ach nee man, oh, stupid pen, waste my time. Okay, we're going to change the divide to a times. What was at the bottom goes to the top, and what was at the top goes to the bottom. Okay, and now we can do some cancelling out. All right, so let's just move this down. Oh, we're running out of time. Okay, so we can cancel. 2 goes into itself once, and 2 goes into itself once over here. Right, there's not really anything else that we can do. 2 times 1 is 1. And then this is the bit that you may not know. Root 2 times root 3 is root 6. Okay, so when we are multiplying 2 roots together, we're allowed to keep the root sign and multiply the numbers. Okay, so that's where root 6 would come from. Okay, does that make sense to everybody? And again, this is something that would have been sort of first explained to you in grade 10, in grade 8, that you're doing now. Now, one last thing that I want to say before I go, okay? Nizola, you said, how would they know if you use a calculator? If you ended up with, this is your answer and you'd use a calculator, your calculator is not going to give you that as an answer. Your calculator is going to rationalize the denominator, which is something that you're only taught how to do in grade 11. So that's how they would know that you'd used a calculator in this particular question. Okay, so you'd have to show all your steps like I have and then end up with an irrational denominator. Okay, and then they would know you hadn't used your fraction, your calculator. All right. Don't know what happened to my load shedding, but it's 6 o'clock. How does everybody feel? Is that okay? You happy? Makes sense?
Okay, everyone seems happy. I'm glad to see that. I think Miss Franklin may have just hopped off. So before I answer some of you guys the comments on the chat, I just want to know. I know we already spoke about this on Tuesday, but I see new names, so I'm just going to ask again. How many of you are finishing your exams before next Tuesday? Like, I want to know if you have paper 2 before next Tuesday. Just write quickly on the chat. I just want to see. I know a lot of you already answered on Tuesday, but just again, thank you, Kache, for responding. I can't see who's speaking. Megan is writing paper 2 on Monday. Oh, okay. So basically, most of you, is there anyone who's writing any paper after Monday, like from Tuesday onwards, who has any kind of exam for maths? Jared, when's your exam? Okay, Lesejo as well. Okay. No, thank you very much, guys. You can keep your answers coming for the next few seconds. We'll see you. So we'll confirm. I know we said we have a Q&A next week, so I'll just confirm. We just need to tidy up some data so that we know how better to do things depending on the number of people that still need either paper 1 or paper 2 or both. So we'll let you know. We'll communicate with you and let you know what's happening. And yeah. Also, great for you, Nomusa, that you're done, but you're still here. So that's good to see such commitment. I'm going to let you guys go now. I'm sure you've had a long day. I'll see you possibly on Tuesday, most likely on Tuesday. So yeah, but we'll communicate with you. Goodbye, everyone. Enjoy the rest of your evening. Cheers.